Hello everyone. So in the last video we have studied different types of morphological operator like dilation and erosion. So in this video we are going to study a new operator is known as opening. So in last video we had studied the type of morphological operator like dilation and erosion. The dilation is I think where I can dilate the image, I can grow the image by using some structuring element. Means I can use a structuring element B on A so that the shape or a size of A can be increased using a structuring element that we had already studied in the last video, how to dilate the image with a structuring element. Also, I can shrink the image to the certain extent by using erosion process. Again, you will be using the same structuring element which is made up of foreground pixel, and you will place this structuring element on the input image so that you can erode some part of an input image to a certain extent. Now the opening is nothing but the morphological operator which is comprised of two types of morphological operator are erosion followed by dilation. So it is defined as erosion followed by the dilation. Means if you see the original image, if the boundary of the original image is nothing but this, which gives a actual shape of original image, but if you see the output, the sum of the part has been eroded away from the input image using opening as a morphological tool or morphological operator. It has two combination of morphological operator, that is erosion and dilation. Erosion followed by the dilation, and because of this only it is less destructive than the erosion, because if you use only erosion you will be able to remove a maximum part and you will be able to retain very minimum part of a foreground pixel. Okay, so this boundary, inside the boundary you can say the image is made up of foreground pixel, so we represent uh, foreground by 1 and background by 0. Okay, so this is the image and beyond the image there is a background. Okay, now how we process the image. So gray level opening consists simply of gray level erosion followed by gray level dilation. So we are using a gray level erosion that we had already done in a last video, and followed by the gray level dilation. So we will take a structuring element and sliding it around inside each foreground region without, so we are considering the foreground boundary. Okay, so we need to fix our structuring element within the foreground image, within the ones. It should accommodate within all ones, then only you will be able to retain the foreground in the image. For example, if you're considering an example, this is nothing but the example. If you take, wait a second. Okay, so this is example. Okay, now if you consider the input image, you are able to actually have the opening output by this. Okay, no, this is the example of closing. Okay, this. So if you have the input image which is made up of this foreground pixel and background pixel, foreground pixel and background pixel, I can place my mask that is made up of all ones. So I can place over here so that I will be able to accommodate, I will be able to place my mask inside the foreground without touching a background pixel 0. If this is the criteria, then you will be able to retain the foreground, otherwise it will be considered as a background pixel. Okay, now suppose you're considering this input image as an example. Let me show you properly. Now in this input image, I will select this structuring element or a kernel in a such a way that I need to match all ones with all ones of an input image. If I place here, I won't be able to match because of this first box pixel. Behind one there is a 0. But if I shift to the right now, okay, 1. 1 coincides with the background one, or you can say the input image 1 is matching with the structuring element 1. 1 1 1 1 1 1 1 1 1 1 and 1 1 means my structuring element can reside inside this foreground. And if again you shift by one more column, no, the one box, that is the third box, is not matching with the input image. Okay, so the possible location will be like this. So I will consider, I will retain all these foreground pixel value like 1 1 1 1 1 in output image, the entire 9 ones. Also, if I go for the another location, that is I am dealing with the boundary of a foreground, I'm not considering the background, that is 0 0 वाला. मैं खाली बैकग्राउंड फोरग्राउंड के बाउंड्री पर ही मैं मास्क रखने वाला हूँ. I don't want to deal with a background pixel. Again, you can actually place or you can accommodate your structuring element within this foreground. So that is why I can keep the foreground pixel in this area, like I was keeping the mask in this area and in this area. So I have this and this. And if I shift, yes, I can keep my structuring element within the foreground area. The only positions are like this because of mismatching, or you can say this because of mismatching. Now this mismatching is coming because of these two pixels, so I will eliminate these two pixel. I will replace this foreground pixel to the 0 0. So 0 0, so 0 and 0 0 and 0, because I cannot accommodate my entire structuring element within the foreground pixel because of these two elements. Okay, so I will set this background pixel, sorry, foreground pixel in input image to the background pixel 0 0. Similarly, for this remaining two, no, I cannot fit my structuring element within the foreground, so I will eliminate these two, 1 to 0, 1 to 0. Okay, so the only part that you can remove from the input image is this one, this one. Now, if I place, after removing this foreground pixel, the unwanted foreground pixel, means I have opened my image using opening. Okay, means what? Now, if I place my structuring element, yes, I can accommodate. Yes, I can accommodate. Yes, so everywhere I can, my actually structuring element is fitting within the foreground. That will be the actual opening output. Similarly, if you go for this another image inside the input image, yes, I will be able to fit my all this 9 pixel within the input image. 9 pixel of a structuring element within the input image. So I will keep it this area as it is in the output all ones. Similarly for this, all 9, yes. Similarly for the next, and then next. Okay, for this again, for this, yes, I can keep or I can accommodate the area in the foreground pixel by the structuring element. So if you shift here, yes, I can keep it. Yes, up to this I can keep it. Up to this I can keep it. Up to this and this. Okay, the only area is here. There is a mismatching. So if you consider these two pixels are unwanted in order to fit the structuring element in a foreground, so I will eliminate this 2 pixel, or I will replace this foreground pixel with a 0. That is why 0 and 0. So this is the output of a opening. Okay, so it is nothing but you have eroded some part of your original input image, and you have now the eroded version after dilated of output. So after the opening has been carried out, the new boundaries of foreground regions will be such that the structuring element fits inside them. Yes, and so further openings with the same element have no effect. Okay, and this property is known as idempotence. So idempotence for the opening process. So this is the type of morphological operator, that is opening. Means if I want to erode to the very certain extent, I don't want to erode in a larger perspective, so I can go for the opening. Only the unwanted area that I want to eliminate from the image, so I will go for the opening. Okay. And if you had seen the last video, I will show you the output of erosion. This was the erosion. So we were taking this as a structuring element. This is as the input image. This is a output image after a erosion. So if you have this bigger size of a image, and you have been uh, actually reduced to this, so you have reduced your image to very small extent. You have eroded the maximum part from the input image because of the erosion. But with the opening, you can actually, you cannot, it cannot be destructive. If you consider the opening, it will be very less destructive than the erosion. That is the application of opening in the digital image processing. Okay, now the next part that we are going to study is closing. Similarly, like a closing opening, the closing tends to enlarge the boundary of a foreground. The foreground are nothing but your bright regions in the image. So I can add the extra part to the image, input image. This one, if you consider the boundary represents the foreground, and beyond the boundary background. So you have added some foreground to the original image. The effect of an operator is to preserve the background region that have similar shape to this structuring element while eliminating all other regions of a background picture. So here we are dealing with a background boundaries. We are not considering a foreground. Okay. So the process is defined as, the closing process is defined as dilation followed by erosion. So first you will dilate and then you will go for the erosion. That is the process of closing. So gray level closing consists straightforwardly of gray level dilation followed by gray level erosion. So we'll take a structuring element and then we will slide it down around outside each foreground region without changing its orientation for any background boundary point, if the structuring element can be made to touch that point without any part of an element being inside a foreground region, then that point remains a background. For example, this. Okay. Now we are going to do the closing procedure, that is a morphological operation. Okay. Now here you will see where actually I can accommodate, where I can fit my structuring element inside the background. Okay. Now if I place my structuring element for the background, yes, I can fit it, because when you have nothing out of zero, you will consider it as a zero only. You will pad this image with a zero to actually solve the problem. Again, if I want to solve for this pixel, yes, 0 0 0 1 0, I can accommodate my this structuring element. Now I'm dealing with only the background, that is zero. Wherever I can accommodate my structuring element, I will be able to retain some background in the image. Okay, for this position, yes. Then I'm not going inside the foreground. I'm just dealing with only the background. Yes. Yes, here also I can fit my structuring element. Now when you come for your foreground, that is the image. Now here I can fit the image. So up to this I can fit. But if I go for this, no, I cannot fit my, there is a mismatch. Okay. So I will replace this background 0 with a ones. 1 1 1 1, then 1 1, and then for this part 1. So if you take your structuring element at the output, then you can accommodate your pixel here now. So wherever you cannot fit your structuring element inside the background 0, you will replace the 0 by foreground pixel 1. Here 2 by, you can say 2 by 2, 2 by 2, so no, 2 by 2, 2 by 2, no, from 3 by 3, so 3 by 3, yes, I will retain its background 0 for 3 by 3. Other than less than 3 by 3, no, 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 so I will replace this 0 as a 1. So I'm considering the black background boundary. Similarly for this pixel, I cannot fit for a 1 pixel. I cannot fit my 3 by 3 structuring element inside this single pixel, so I will replace to the 1. So that is why now I can fit my structuring element over the foreground. Okay, similarly for this, no, this, no, this, no, no, I cannot fit anywhere inside this background, so I will replace all zeros with 1. Sorry, I cannot fit my this, no, I cannot fit anywhere, no, but I can fit here 1 0 1 0 1 0 1 0 1 0 1 0. I can fit here 1 0 1 0 1 0 1 0 1 0 1 0 1 0. I can fit over here 1 0, so I will keep the background as it is. I can preserve the background. the black background which is made up of 0. So that is why in output you will preserve the background. But wherever you cannot fit your structuring element, you are going to replace the zeros with all ones. Okay, like this, and you will means you are closing the unwanted area in the image. So you have filled some part in the original input image by replacing 0 by 1. Okay, so this is the application of closing. You're closing a part. Hmm. Here I cannot fit at all because it is a 2 by 2 if you consider the foreground. No, this one also, this pixel, I cannot fit my 3 by 3 inside this background, so I will replace it to the 1. So 1, so here 9 by 9. Okay, here 9 by 9, 9 by 9, 9 by 9. Oh, beyond this background 0 you have multiple 0, you can say the grid of 0 background, 0 0 0 0 all over this. So that is why you can fit your 9 by 9 for this pixel, 3 pixel, you can fit anywhere. The image is only made up of 4 rounds, so we'll consider this image. So if that was actually the input, after closing effect you are able to fill some foreground within the input image in those area where you cannot fit your structuring element inside the background. So this is the type of another type of morphological operator. Then the last type that you have in your syllabus is hit or miss transform. Hit or miss transform, or hit and miss transform. Okay, so hit or miss transform. So till now we have studied a different structuring element, the structuring element which is actually made up of all ones. Now in a hit or miss transform, it is a combination of 1 and 0. And if you see in a structuring element, if there is no any value, means you will consider as either it can be considered as a don't care, you're not actually you're not giving any weightage to that, you will keep it as it is. In a some book they will specify the don't care condition. Otherwise in some book, if you find there is no any pixel value, you are not considering any value, means you don't bother about that value. So that is why don't care about this pixel value. Now the structuring element can contain both foreground and background pixel. The structuring element can contain both foreground and background pixel. Foreground means 1, this one, this one, this one are foreground pixel. 0 0 0 are background pixel, rather than just foreground pixel. So in dilation, erosion, closing, opening, we have studied only the structuring element which were made up of only all ones. So here we have a mix strategy, that is we are considering 1 and 0 in a structuring element, 0 as a background, 1 as a foreground. Okay, now how we use the structuring element in order to get the hit or miss transformation on an input image. Now it says if the foreground and background pixel in a structuring element exactly match foreground and a background pixel in a image, that is the input image, means you are considering a foreground pixel and background pixel of a structuring element. Okay, and you are considering the image, you need to match the foreground pixel, that is 1 should be matched with 1 and 0 should be matched with the 0. Now to match this we are going to consider the angle convex. Okay, so if you consider this structuring element, in this structuring element, if our structuring element is made up of 3 by 3, huh? So first structuring element, if in the examination it has been given like, if you have a structuring element, please do the hit or miss or hit and miss transformation on the image and get the output. So you will see at this structuring element, as it is 3 by 3 structuring element, you can say 0 0 0. It is means the zeros are making a right angle convex, this right angle convex, okay, and this one is also making some right angle convex. So either you can consider zero angle convex or one angle convex. We will see by using both zero and one angle convex. Okay, first we'll consider this. Now it has been given in an input image. Suppose you have the structuring element like this. Okay, this and this both are similar. If you don't have anything, you will consider the don't care. In some book or in some question paper, they will give you the don't care. If don't care is not present, then you will consider nothing here. Now if you consider this, the second structuring element, it is means you have rotated your structuring element in such a way that it will come like this. Means you are having the leftmost bottom right angle convex by all three zeros. Now you have a rightmost right angle convex now because of this structure. Then you have upper rightmost right angle convex, and you have upper left right angle leftmost right angle convex because of 30 30 30 and 30. Now if we are considering the zero right angle convex, okay, this is the example. So if you have an input image is like this, if you have the input image is like this, now I need to match foreground pixel and background pixel. Now this is nothing but the output of hit or miss transformation. Now first, suppose if I want to start from the first pixel this. Now what kind of structuring element I need to choose? Now here it is making a right angle triangle, these three zeros. So where it is this, okay. So if I use this, I will show you. If I, yes, I can match this 0 with input 0 0 0. Now here don't care, I don't need to consider that. So 0 0 is matching, 1 1 is matching, this don't care, this don't get this. I less bother about the don't care, I just want to match 3 1 and 3 0. So I can replace by matching all three zeros and all three ones. I can replace the target pixel to the foreground, that is 1. So in output you will find there is 1. Now if I shift, no, I cannot match 0 0 1 0 1, means this one, I can match these three ones, but all three zeros are not matching. 0 के पीछे 1 है, 0 के पीछे 0, 0 के ये थोड़ा सा difference आ रहा है. That is the your fourth box. Okay. Hmm. Yes. Yeah, getting a conflict in this box. You can match 0 0 this 0, but not this 0. This one, this one, this one. Yes, the condition is satisfied, but not for this box. So I cannot actually put a target pixel to the 1. So that is why I have created 0. Similarly for the another pixel, no. Okay. So this is making a right angle triangle, this is making a right angle triangle, so I can preserve this bit also. That is why 1 like this, 0 0 0 1 1 1. So I can keep this target pixel as it is in output image 1. This is your output, desired output, hit, yes, hit. When you miss any kind of pixel, then you're going to keep keep it as a 0. Okay, this is one of the structuring element or the angle of convex, uh, which is the upper leftmost right angle we have used for this, because you are making this kind of right angle. Now if you consider this, no, you cannot hit the image over here, so you cannot target this pixel value, so I will keep it as a 0. Now here, for this corner foreground pixel, for this corner foreground pixel, you can match this with that type of structuring element. So if I place, sorry, okay, so 0 is matching with 0, 1 is matching with 1, 1 is matching with 1, 1 is matching with 1, 0 is matching with 0, 0 is matching with 0, 0 is matching with 0. Means what you want to match actually, I will show you. Okay, you need to match only this, the remaining white squares I don't care. Similarly for this, you need to match only this 6 pixel. Okay, and the box that is not shaded one, don't care condition. Now if I place this mask over here, yes, I can match now 0 0 1 1 1. So I will replace, or I will keep 1 as it is in the image. Hmm, like this, sorry, 1 2 3 4 5, 1 2 3 4 5 for this. Okay, yes, this right angle, this middle, yes, I can keep it as it is, 1. Similarly, this right angle made up of your 0, I can keep it 1, like this. For next, like this. Okay, for, yes, I can match this. So I can keep in the output 1. So wherever I will be able to hit with the right angle convex, 0, and when I will be able to satisfy that I am matching all these 3 zeros and 3 ones exactly similar uh, to the input image, then I will keep it the middle pixel as 1, so that you are getting this. Now here, no, you cannot actually match for this pixel. I cannot have the angle around the 1 0. I can have the angle around the 1 like this. So you can actually target the corner only. Hmm. Now for this pixel, I will be able to retain a foreground 1 because of this mask. Okay, 0 0 0 is matching with 0, 1 1 1 is matching with 1. So all ones are matching with all ones, all zeros, 3 zeros are matching with all 3 zeros. So that is why I will keep 1 as it is. Okay, okay. So this is the process of hit and miss transformation. At So we can actually target the corners, this corner. Yes, you are having this rightmost bottom right angle, so you are going to use this structuring element to preserve this. So you will be able to preserve the foreground in the image. Means actually the heat or mesh transformation gives you the basic boundary or how can be the image. You can redraw the image from the boundary. Means if you consider this M as image, you can actually create your a boundary uh, of a M. Similarly, for this image, you can create the boundary of this input image like this. Okay, and you can reconstruct the image again from the heat of image transformation. Okay. Hmm. So this is the one method to actually perform the heat or image transformation. The another method, if you want to consider the once wala angle convex, uh, like one wala, you can consider it like this. Okay, so if I am considering one wala angle, जैसे ऐसे हो गया, one is the type like this. First I will try to find the match right angle like one. तो कहाँ पे मिलेगा, देखो, if I keep over here, where is the background? Oh, okay. Hmm. Now your one is matching with 1 0, means you are considering this angle, and beyond this angle you need to consider these zeros should be match in the input image. So you can consider the one angle in order to retain some foreground in the image. Okay, then if you go for this convention for one angle convex, you can consider the image and you can actually transform the image using heat or image transform. So you can go either way by considering zero angle or one angle. It is up to you, but you need to match all these pixels of your structuring element with the input image. So we have studied all this type of transformation after using a morphological operator like dilation, erosion, hit or miss transformation, closing, opening. So for particular application, for the specific application, if the application is to only uh, eliminate some part of an image by not actually eroding to the that larger extent, then you will go for opening. Okay, so these are nothing but the morphological operator that we have studied. Thank you.